Hi and welcome to this second video on retrieval augmented generation, where we will start looking at the search part. So the purpose of this video is explaining you how you can use search capabilities of Elasticsearch or Atlas Search to solve, to find pieces of document segments that contain some keyword and pass to a large language model to answer a user question. I know that vector search is a really hot argument these days, but before going into looking at what a vector is, I need to warn you. There are a lot of existing and well-proven techniques to find text based on keyword search. Google does this for a lot of things and it is exceptional. You have libraries that are capable of performing keyword search in a really efficient way. So before trying to try this new vector stuff made possible by a large language model, by a language model, let's stick to what we already had before artificial intelligence and before large language model, because I assure you that it's enough for many situations and you need to master keyword search before going into some more advanced topic like vector search. There are a lot of books about natural language processing, keyword searching, book about Elasticsearch, Lucene, Atlas Search. But I strongly suggest you, if you want to have a good look and a good introduction and some advanced technique you can use, this book, Relevant Search, is the book for you. This is a really invaluable book because it contains a lot of valuable suggestion and it can be read as an introduction to searching, to keyword searching, but it will guide you into much more advanced concept. And at the end of the book, you will be much more proficient in mastering the art of keyword searching. Basically, everything in this example starts with a keyword search. So the user is giving you some keyword that are used to find the segment that contains those keywords. And basically, you user some sort of search database for accomplishing this. And Elasticsearch is probably the most known tool for searching, or you can use Solar, or you can even use Atlas Search, MongoDB Atlas Search, because all of these products are based on Lucene library. So it is a well-known and standard library used to allow you for keyword search, and it will use some standard algorithm in literature like TF-EDF or like BM25. I'm not going into the detail on how this algorithm works, but basically the whole purpose is taking a piece of text, index into what is called an inverted index for super fast retrieval, where the search engine, the Lucene library, is capable of giving you the piece of text that contains keyword you are searching, and in an order where the first document the library returns to you is the more pertinent about your keyword search. And BM25, TF-EDF, and other algorithms are meant to give a pertinent score, a score that can make the most relevant document first. And that is the reason why the book I've suggested you is called Relevant Search. Using Atlas database gives you an incredible advantage because Atlas introduced recently a function called Atlas Search, where Atlas directly gives you a search capability based on Lucene, so it's very similar to what you can have with Elasticsearch, but you don't need to install or to have any other tool. You just create a search index upon your data in Atlas, and this is very interesting. Now, let's see how you can create a search index on your Atlas database. Everything I'm going to show you, it can be done by code. So usually you create search index by code. You don't require some administrator to go into the UI and do everything manually. But doing this manually, it's interesting. So I can browse collection, and so I can look directly from the portal what is inside my database, and then I can click search. And search open the area dedicated to Atlas search, in which actually I have not a single index. In your free tier, in your M0 free tier, you can create, I think, up to 3 indexes. So if you really need to go into production, you will surely need to have one of the instance of Atlas, not free because it gives you much more capabilities. But actually, all the feature you have in the pay version, you have in the free version. So this is exceptional because you can try everything in your free version. So you can try if Atlas is the product for you before going to spend money and put into production. Creating an index is really simple. You can click create an index, use the visual editor, or you can use a JSON editor. JSON editor allow you to specify the index with a JSON file, and it's the same JSON file you can use with code to create an index programmatically. But now let's do with the visual editor. Then I need to give a name to the index. I call it segments, and then I need to select one collection I want to index. This because you have an index for a single collection, and Atlas will transfer automatically the data from the collection to the search index automatically as soon as you update the data. So this is fantastic because you don't need to do anything to transfer data from your database to your search index. It is done automatically because everything is into Atlas. Now I would choose document segments because I'm going to search inside segments, and I press next. Now it is starting, Atlas is starting to ask you for configuration, and you can refine your index, and you can choose to not to stick with the default option and to give your option. So usually you can start using the standard in the default option. The default option will index everything in a collection with standard analyzer. Okay, now I'm going a little bit more into the not advanced mode, but a custom mode, where I will uncheck dynamic mapping because I don't want the index to contain everything. And sorry for a noob mistake where I've recorded all the parts of the previous video and up to this part of the video using the wrong microphone, and I realized just now that I've used the wrong microphone. Sorry for this. Now that I have the right microphone connected, I can proceed to add a field mapping. The concept of field mapping will be clear in a subsequent video. For now, I want just to show you how you can decide which properties of the document are going to be indexed. And this is usually needed to reduce the index size because probably I don't want every part of the document to be indexed, and also I can tweak how the index is created. In this situation, I choose to index only the content part of the segment. The data type is a string, and I can use and I can use Lucene standard analyzer, and the concept of finalizer will be clearer in subsequent video. For now, you only need to know that this is a standard analyzer that is capable to analyze standard text without any language specific feature or any specific feature. Is an all-purpose index that allows you to search for keyword in a most generic way possible, okay? And after I simply selected this, you can leave anything else to the default. You can click add, and actually you can go and save changes. And now you have all the recap of how you have created your index. You have only one field indexed. It's a content field, it's string, and you can view all the properties in its Lucene standard, and then you can create search index. And so the index is not started. You just need to wait a little bit for the index to start. while we are waiting for our index to start, it will require almost 20 seconds for the free instance. I just want to explain you why Atlas and MongoDB is one of the winning choice for your data. Because when you, even for the free instance, and all the instance in Atlas had at least 3 distinct machines that holds your data. This means that if one of the machines start failing, you have a couple of other machines that are available to answer, to store and retrieve data. So this is really high availability because you are sure that your database will be always available because it's served by 3 instances, and the only way you can have a problem is if 2 instances failed at the same moment. Okay, so this is usually not a typical scenario. So you are sure that your data will be always available. Now, the status of the search index, my segment search index, is active, and you can see into the details that the search index is also subdivided into all 3 instances. So your search will be high available too. And also you can see that all the 48 for document are indexed. So this means that Atlas automatically takes the data and move to the search index for you. Now, the question is, why Atlas Search instead of maybe Elasticsearch, that is de facto a standard in this scenario, or AWS, Amazon Search, on Azure Search that are also based on variation of Elasticsearch? Well, my opinion is, first of all, you don't need to install anything else. You already use Atlas. You already know how to use Atlas. You already have your C# code being able to interact with Atlas. It's the same product. It is just normal to use search capabilities if they are enough for you. And surely they are. And then you don't need to put in place any code for you that each time you update your primary database, Atlas is going to update your search index. This is because Atlas performed this for you. You just choose the collection and you just configure the index, and each time you are going to update that or insert new documents inside the collection, Atlas will immediately update your search index. And it's based on Lucene. So basically you are expecting to have the same search capabilities of Elasticsearch, TF-EDF, BM25, and so on. So it also is high available as the rest of the database, so you don't need to put in place more instances of Elasticsearch or other product. It is already high available like all the rest of the data. So it's probably the right choice, the right solution, at least for starting, because it is already available and it's already there, and it's always based on Lucene. So you really can expect the very same capability you have from other product. Now it's time to look at the search in action. I'm not going to show you a lot of the code because I want to give you the idea on how everything works. So I press load from disk, and as you can see, this is a Unix path because this is this to show you that I'm actually not using Tika to extract data. I'm just loading from database, from MongoDB, everything. Now I can choose a keyword search like complete mediation, and I can press keyword search, and I can go to the keyword result and look at the result. So I found with keyword search some segment from the database that satisfy my keyword search. One good thing about Lucene search that is available in Atlas search is that I can ask for a highlight. Highlight allowed me to ask to the search index, please give me the path, the field where you matched my keyword. I have only the content field, so it's not useful in this situation. But if you indexed a lot of field, it's useful because you know where the keyword was found. And then I can ask with a highlight, the highlight of where the index find data. And so you see this document as complete mediation. I can scroll down, I go into the latest document, and you see complete. So actually, as you can see, it is searching for any of the word, but since the first segment contains much more match, it is
first document, but you have also the ability to search with and, okay, complete and mediation. Now I'm asking to perform a search where I want both the keyword to happen to be found in the document. As you can see, I have only 4 results because actually I want both keyword be in the document. I can also use double quotes to intend that I want the exact phrase complete mediation without any word between these two words. And it's very like Google syntax. And this allows you to search in a super fast way inside your search database. And the key for this is BM25 and all the algorithm used by Lucene are really super fast and are meant to search your keyword in literally terabytes of data, millions of documents in very few seconds or milliseconds. Now we finally interact with a large language model. So where does the large language model find place inside this scenario? Well, if you are looking for an answer like, can you please explain the technique called complete mediation? As a user, I can simply perform a keyword search, complete mediation, and then I need to start reading all the segment returned from my search and find my answer. But clearly, if I have large language model, I can use a much more smarter way of answering a user question. I use the keyword to find the important segment of text that contains potentially the answer. And then I'm going to create a special prompt to the large language model where I'm telling the prompt, hey, these are what I found from my segment collection. And this is the question of the user. Please give me an answer if you can. So if I press question, what I have is I'm going to interact with a large language model with GPT 3.5 with API, and I can, for this example, look at the debug section of the software that is explaining me what happens behind the scenes. Now, first, I have an Atlas search. Okay, so this is the query I made into Atlas, and it's really interesting because it is a standard aggregation query. And if you know Atlas and MongoDB, you can look at this query and you find familiar. So this is another reason for using Atlas search. You can reuse your existing knowledge of how to query Atlas database to use the search index. And then the Atlas search returned 5 elements. And finally, I'm going to call a large language model. So that is what I'm passing to the large language model system. You're a chatbot that will answer questions based on the content included in the prompt. You will never use your memory to answer the question. I'm giving a context and then answer the question based only on the following context. If the context does not contain answer to the question, you will answer, I have not an answer. Then I'm going to pass all the segment I've found from the keyword search, and finally the question of the user. Can you please explain the technique called complete mediation? Perfect. And now I have the answer of the large language model. With complete mediation principle, a system should validate access right to all its resources and blah, blah, blah. So actually, I found the exact answer to the question of the user. And this basically concludes this second video where I show how you can use a large language model to answer a user question. And as you can see, we have the first video, we learned how to use Tika to extract text from a PDF from a document. We store the text inside the database with the MongoDB database. Then we use a custom C# code to divide in segment. And then we create an Atlas search index. So we can let the user specify some keyword search that will be used with a BM25 algorithm to super fast retrieve segment of text that contains the keyword. Then all the segment of text are passed to a prompt to the large language model to answer the query. And this is what usually is called long-term memory, because the large language model has a sort of memory due to the training. But in this situation, the purpose of the large language model is analyzing what I'm giving you, what I'm giving it. So the concept is I use keyword for super fast text retrieval, then I take all the text and I pass to the large language model to have an answer. So this avoid the user the need to read all the text that are returned by the keyword to understand if it answered to its question. And also the large language model can formulate an answer for you, giving an immediate answer based on what you passed as a context. And this concludes the second video. And this is the very first simple example of retrieval augmented generation. So keyword search, use a prompt in the large language model, answer the user question. See you in the next video.